Welcome back to the course Privacy and Security in Online Social Media. We are in week 3 and part 2. Just to recollect on what we did in the last part, we started looking at the social media data. And in week 2, you saw how to collect this data, how to analyze this data, all of that. And week 3, first part, we started looking at how what text is available in the data and how this text can be used for making any useful inferences from the data. So today we'll continue about this part. We'll continue about analyzing the text of the social media data. Large data, so this part I think now you must be very, very clear on. Large amount of data is coming from social networks. We have posts, comments, reviews, all of that coming from any platform that you think, meaning if you think about Reddit, if you think about Facebook, Twitter, Insta, any of these platforms, if you see some form of text content is always there. And how to make sense out of this, right? What do we do something to help make any inferences from the data? So some of the insights that we could get is opinion towards a product. You're a marketing team. You're a CEO of a company. You're a designer of a product. You want to know what the customers are saying about the product, right? You're curious to know what people are interested in saying about the product. Detecting hate speech, like if you are working for, again, NGO, or if you're working for a government agency, if you're working for an organization which is which intends to actually reduce hate speech on the internet, then you're probably looking for those kind of content that are posted, right? What are people talking about, right? In general itself, you're interested in what people are talking about, general topics that they are interested in. Right? So all of this to get the insight we saw last time, right? Some tweets are available and you want to get sense out of it. So now what to do with that text, that's what we're going to look at. Posts, this is still same, right? This is still same. We wanted, now our interest for this part of the week, this part of the content is to find out what are the things that we can actually try. Please remember again, the goal for this class is not to get into details of these algorithms itself, because I think that will get into NLP, that will get into more of machine learning, reinforcement learning, deep learning methods for text, all of that. The goal for this class is, look, there is social media data. What interesting things at an abstract level can you do to take some inferences from this text and do what we want? Because our goal is to find out PII on the data, right? Our goal is to find out hate speech. Our goal is to find out fake news. Our goal is to find out is there privacy leaks on the social media content. So one method could be rule-based methods. If there is an abusive word, it could be hate speech. Right? Simple methods. These are rule-based. You just set rules. Oh, if there's a word called idiot, right? If there's a word called fat, blah, blah, blah. All of this, if it's there, just try and say that it's actually of the hate speech category. Then there is other methods which you can think of as machine learning, which I kind of hinted before, which we will not get into in detail. We'll get into some idea, but we'll not get into detail. Right? It could be regression, it could be support vector machines, it could be neural nets, it could be deep learning. All of that methods could be used to find out whatever we are interested in. Whether they're talking about product, whether they're talking about my organization, whether they're talking about political party, all of that could be done. Rule-based method, handcraft, right? Let's look at some methods. So these methods, for your understanding, will give you a sense of what can you try. What can you try with these methods? How much analysis can you do? What can you infer, right? So first method, rule-based, handcrafted rules, as I said. Simple but fragile because limited by coverage of rules, because one cannot come up with so many rules, right? I mean, you don't even know what the rules could be, right? So to start with, you can set up the rules. You can set up saying that, oh, person with height 5.5 and head complexion so much, blah, 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 blah. You can just turn it into a female, male, all of it, right? I'm just giving you an example outside the social data. But unfortunately, this list could go on, right? I don't know how to enumerate everything that you can think about, because there are going to be corner cases, there are going to be features that we'll probably not be able to capture. In social data, again, hate speech, you can think of words, you can think of pictures, you can think of features in the text, but it's not clear whether we can actually craft every single rule that is possible. Handcrafted rules works. It can capture majority of the problem, but it's not going to capture all the problem, right? And it's also hard to maintain this crafted rules. Creating the rules, updating these rules. It also depends on where these rules are kept. In traditional security problems, the virus detection, all of that, right? If these rules are kept in client, which is the desktop that is running, laptop that is running, then updating that desktop and the laptop is very hard unless the user actually updates it, right? So virus protection mechanisms find it very hard to be very successful is because of one of the reasons is this, because users don't update their operating system, update the software very frequently or when necessary. Therefore, these rule-based systems generally have the limitations of have certain types of problems. It can only solve certain percentage. So let's take certain types of problems. So if good present in the text pauses sentiment, right? You can think of one of the critical things that I'm sure you are also interested in doing with the social media data is sentiment analysis, which is you're from an institute, ABC, you want to understand what social media people are talking about it. Is it good, bad, ugly, right? Some categorization you want to give, so you are interested in finding out. So the rule could be, oh, if they're using a word good, I had food in the mess, the food was good. Right? I had a food in the mess at ABC, the food was good. So now you're saying that, oh, somebody's saying something positive about it. Movie was really good versus movie was not really good, right? So there are even going to be problems because now the movie was really good, you're probably going to catch it as positive. Really good is positive, but then we have to also keep in mind this not is here. Right? I mean, these are all very hard problems. I'm just trying to highlight these problems for you to keep in mind. I don't think so. The goal of this class is to address some of these problems, but these are all problems that you may have known otherwise also. Keeping the sort of say language, keeping the linguistics, NLP, if you've taken any of the courses or understanding of it. Movie was really good. Movie was not really good. So now let's look at some machine learning methods. Again, slightly at an abstract level, can leverage large data, meaning I think that's the goal of some of the courses like this, right? We are getting large amount of data from social. Can we actually make sense out of it? can learn complex functions, things that we don't see, things that as human beings we cannot decipher, we cannot create a feature for it. We don't see millions. For example, one of my favorite examples is that if I give you 1,000 tweets and tell you, tell me the tweets that had positive versus negative sentiment by only using Excel or by only doing manually how much time you're going to take, versus a machine, a program to look at it and tell me how much positive, how much negative it is there. It's going to be much, much faster. So the large amount of data available, we should leverage the computational techniques that are available to understand. And some complex things also, right? By human, if we do, there's going to be a lot of error. By rule-based, we're going to miss some rules, and therefore learning methods, machine learning methods are going to be very, very helpful. So the key is also to leverage machine learning algorithms. We need to convert text into numbers, which algorithms can crunch. Text to numbers, text to some features, text to something that it can understand, right? The problem of this one movie was really good and movie was not really good. Program is not going to understand. Program is not going to understand that not part of the text given to it, right? Numerical representations of the text, whatever the text is, movie is really good. Can we actually find a way to represent in numerical form so it can learn quickly, because it's very, very good at crunching numbers, right? Embeddings would also mean the same thing. One of the buzzwords that you may have heard in the last, let's take 5 years, a decade or so, is this embeddings, right? Create embeddings for a user from Twitter. Create embeddings for paper that you're writing. Create embeddings for image that is given to you, right? These embeddings are nothing but numerical representation of the data in some ways that the program can understand, computer can understand. A simple example for representation of bag of words. Bag of words is another interesting technique and a very, very popular technique also to study text given to us. So bag of words, text corpus. Here is a text given as an input. I love IIT Madras, Chennai as metro. Right. Vocabulary. I love V is equal to 7 unique words. I love IIT Madras 4, Chennai 5 has 6, metro 7. There are 7 words. Then the unique words are here. I love IIT Madras, Chennai has metro. I mean, it's just an example. Example here is only driving a point that how do you get from this text to the embeddings that we're talking about, to the numerical representation that we're talking about. Right? So this is the vector. Each position is associated with a word, one equal to the word. That word is present in the sentence, right? So if there is one, then there is word there, one not there, the word is not there. Assuming that there are only 7 words in the language, we can represent any sentence by 7-dimensional vector now, right? If you think that there are only these 7 words in any of the sentences or language usage, only these 7 words appear. Now you can actually create a vector of these 7 words for the sentence that you're giving. So I can say that, oh, I love Chennai is there. Rest all is 0. Right? I love Madras, we have already seen. It could be that meaning IIT has metro. Right? So IIT has metro. Right? So you can create embeddings for assuming that these are the only 7. Just imagine if this 7 becomes the entire English dictionary, or the entire parts of the image that you're talking about, right? Possible features in an image, right? All of that is the embeddings that we're talking about here. So that's how you will convert a text given to numerical representation. I hope it kind of gives you a sense. Again, feel free to come back with us with questions. We have also set up weekly or regular live sessions with you. We also have discourse. Please come there and ask your questions. We'll be happy to actually talk to you. Text corpus, I love IIT Chennai as Metro. The same thing here. I love IIT Madras. So if you see the first 4 ones as 1, the rest as zeros. Chennai has Metro, the first 4 ones as 0, and then there is 1. Madras as Metro is Madras is 1, has is Metro is here. Right? So again, if you just think of these as embeddings, these as graphs, now you can also represent them as graphs, right? Given a sentence, all of these words are there, then there is links between these words also could form a graph for you. Right? Since vocabulary is large, these representations are inefficient when we scale, right? So it's going to be hard to scale for all words and all sentences that are created. It's not impossible. It's just that it's large. Order, meaning, semantics of the word is important of the task. So for example, if you think about it, one of the things could be how many times each of these words appear in all the text that is given to you. Could be a mechanism by which you draw the graph, mechanism by which you store the data and keep, right? So that could be a way to say that, look, love appears more number of times than IIT in all the word sentences that are written in English, and therefore love should be given more preferences than IIT. Things like that. Do bag of word representation attempt to capture meaning? Bag of words is just generally looking at only whether the word appears or not. Right? So it's not getting the sort of say parts of speech tagging. It's not getting the semantic meaning of the sentence. It's going to look for the word whether bag is there or not. Look for the word is there or not. That's bag of words. So, but if you look at some complex methods, right, we need richer representations, right? Just this, whether it appears or not is not going to help, and particularly just the meaning, just the word being there is not going to help us make much of a sense. Should attempt to capture the semantics. Semantics is important because it's, as I'll show you in some examples, semantics will mean a lot of things. For example, it's coming later, but let me just talk to you quickly about it. Bank, right? The word bank, when I say the word bank, what comes to your mind? Just pause the video and think for a second, right? So if you think about it, you will probably think of the financial place where you keep money, right? But there's also river bank, right? But there's also something like I bank on you, right? Reliable, I rely on you types, right? There are words that have multiple meanings which become river bank, right? This is the second one, this is the third one, right? And there are many words like this, just one of the common examples that people use in linguistics classes. But there are many examples like this. So now, knowing the semantics of the event text will help you to decipher which of the bank are you talking about, right? It helps you to understand which of the bank are we talking about. And knowing that is helpful because it is going to help you decide what kind of usage it's going to have, what kind of inference can you draw from them, right? So these are called word sense disambiguation at some point in time, right? Distributed semantics, a word is known by the company it keeps. So can you now, this small example that I mentioned was this word love and IIT. I said this independently, but you can also think of how many times love and Madras has come together, right? How many times IIT and Chennai has come together, right? So can you find some ways by which to embed the text that is available next to each other or in a chunk and then make some meaning out of it, right? If I can train the model to guess its neighbor words, maybe they can capture semantics a bit better, right? So the goal is to guess the neighboring words. If you get the meaning of if you start doing this well, the meaning of the sentences can also become much, much richer. Here are some examples again. I'm just throwing some things at you. If you are not able to understand some of it, please come back. We'll be happy to explain the discourse, the live session, anywhere. Please stop by. We'll be happy to explain things for you. Given a word, I'll try to predict the surroundings, right? So, so now I can get the word embeddings, which is embeddings I said earlier. So here, distributed representation of words and phrases and their compositionality, right? So the goal is that input a word is given, projection, what are the other words that is possible to come, right? I say that I love dash, right? I am going to dash. We will meet dash week. Some things like this, right? Can you predict all of this is the goal here. Once trained independent task, one can use these embeddings. So if you have the embeddings created, right, then you can start saying, right, which is this word is given. I already have this word. Which word should it be? And when I know that this, so for example, let's go back. When I know that this word is coming, I comes before love, and a location name, which later also we'll see named entity is there. If this is going to be always a named entity, then understanding that will help find out what the next word is going to be. Right. So there are many methods for this: word to egg, love, fast text, meaning you will see some of them in the hands-on lab sessions. How to use it? Again, our goal is, can we use it as a black box? For people who are interested in trying to delve into it, wanting to know about it, feel free to go take a look at the links pointed out here, or these methods to understand it a bit more. So this pre-trained word vectors, right? So which is models trained on all Wikipedia text, models trained on all legal text given, models trained on all Hindi texts that are given, created on Wikipedia. These kind of models that are created are very powerful, and it can help actually make a lot of choices better. Yeah, so this is the example that I said jumped onto earlier, which is a word can have many meanings: bank of a river, financial bank, banking on you. So the static word embeddings are same, irrespective of the context. You end up using the same representation irrespective of the context, right? So if the you want to make sure that the embeddings are also capturing this information of financial bank versus bank of a river. So this created the idea called contextual word embeddings. Earlier we saw word embeddings, given a text, see whether it is there or not. Now I need to get the context into the embeddings also. Recent models like BERT. Meaning, I think if you're going to do anything in NLP today, you need to know BERT. And family are learned using deep learning models. So these models, right? These trained models on a particular context. For example, some of the contexts that we have been using very regularly are legal, right? All legal texts that are available have been used. I think it's called legal BERT. Right. So these models are developed. Now, if I want to run my text to understand what the sentences mean, what the semantics of the sentences given to me are, I just run it on legal BERT than the BERT, the vanilla BERT itself. Is because the vanilla BERT is trained on English corpus fully. It's not trained on a particular text, right? Particular context. Same thing like Indic BERT, all the Indian languages, right? Indian regional languages have been used to train this model, some languages. And now using BERT is not going to be helpful for me to analyze Hindi, whereas Indic BERT will be helpful. That's the idea. Right, these embeddings, these models have revolutionized how we look at NLP today. So the embeddings, right? You want to have all the models, all the things that are pre-trained, so you can keep these pre-trained models available. So when you want to actually test something, it becomes much easier. After obtaining embeddings, use desired algorithms to carry out. So you have your embeddings. Like for example, we did Supreme Court data. We took the UP code data, lower code data, and applied it. That's a specific context, right? Now you don't want to use the generic BERT. You want to use the legal BERT. That's the difference here. If you have the legal BERT pre-trained, it's easy there. Text, embeddings, algorithms to carry out specific tasks. Specific tasks could be, in our case, one of the examples that we can talk about it later is the bail prediction, which is what we did, which is given a court case, application for bail. Let's take the application number 1 is given. We want to actually predict whether the judge will take it as accept or reject. And when he accepts, there's also this money that is put to the bail accept. How much will it be? For now, we did only the accept or reject, but that's what a BERT model can do, a generic model can do, right? Which is given an application, given a text in the legal context, can you actually run it through some algorithms here to say that whether to accept, whether the judge would accept this bail application or not. We had the results, right? Because these are court documents, we had the outcome, and we were predicting whether we could, we were predicting the outcomes of these documents. Right. That's one application. I mean, I'm sure there are hundreds and thousands of applications you can create. which is given a email, can you predict whether it's phishing? Given an image, can you predict whether it's phishing? So now moving on, having collected text data from social data, various types of tasks that you can do, right? You can do topic detection. So you have like tweets that are coming in, streaming tweets that you're getting from morning, or you are getting all the things about hashtag IIT Madras. You want to understand what topic are they talking about, right? You're collecting hashtag Hyderabad. You want to know what topic they are talking about, right? The other one is text classification, which is the more common thing that you'll probably do, which is whether the text is positive or negative, whether a Reddit post is offensive. So all of these are tasks that you can actually do from the text that you're collecting from social. And our goal, meaning your application, is mostly going to be only this, right? What words are most frequently used? I mean, these are just examples. Again, I would highly recommend you to go take a look at some NLP content if you're interested. But here is one that we had done. So the idea is one representation, but I'm sure there are other methods also to use. So this is just saying that what is the word that was used in the data that we collected. This is basically manifesto. We took the manifesto of 2019 of both the political parties, and we said, okay, let's just try and understand what words they're using. After doing all the pre-processing that I had mentioned before, this is the kind of a word cloud that we get, which is what political party you're talking about, right? Development, government, country, 5, government, development, education, growth, work, right, schedule, women, health, economic, right? So you can actually compare. This is just visual comparison, but I'm sure we can do much more interesting comparison if you start looking at statistics of the data that is available through this. So let's just take a step back, right? So this slide is going to give you just a sense of what goes on at a slightly abstract level. So we do training data and their categories. Then we do pre-processing. We talked about extraction from text. And then train to evaluate, classifies to learn features, category mapping, which is this text positive, is this text negative? That's the training process. That's the order in which it happens, 1, 2, 3, 4, 5. Then 6 is use the classifier to predict the new task. Given a new text, can you say whether it is fake news or not? Then new text with unknown categories, right? So you are feeding in the new tweet that is coming. You're feeding in the new email that you're getting. This is 100,000 emails that have been already analyzed, marked as phishing, not phishing, fake, not fake. All of that is already marked and kept here. A new email is coming, and then the 6 is doing the comparison of these two and saying that whether it is fake or not. Right? So that's the kind of thing that you can do with the text that you're getting. Again, that part is only to focus. So we'll actually continue talking about this text analysis in other parts also, because where we have to get, let's take privacy information of a user, to study privacy policies. All of this will end up actually looking at NLP as a tool. That's what our focus is, right? NLP as a tool is what the goal of this focus of this class is. Okay. Thank you for listening to the class. Again, if you have any questions, feel free to post on the class mailing list.